Okay, so on the last topic, we're going to be dealing with graphing compound inequalities. Now, compound inequalities are inequalities that are combined with the word and they specifically only work with the less than or equal to symbols. Okay, so the first one here, number one, the way you read these is a little different. If you're reading it left to right, it'll look like 8 less than x less than 15, but a way that you're supposed to think of it, it was kind of like from the middle out, the way you read it. So what it's going to look like is x is greater than 8 and x is less than 15. What it really means, after we plot down our two locations, is that x is between 8 and 15. So you can almost think of and with a compound inequality at least to be like a number being between like a minimum and a maximum, let's say. So in this case it's less than, so it's open circles. And what we do with these and situations like we did before is we connect the two dots and we have between 8 and 15. Okay. I'm going to do number 3 so you guys can try 2 and 4. So notice this one has the less than or equal to symbol on one of them, well, on both of them actually. So we're going to have -2 and 6, closed circles, and just like the one above, we're going to connect them. Because the way we could read this is y is greater than or equal to -2, and y is less than or equal to 6, which means that it's between those two values. Okay, so go ahead, pause it, try the u-tries. Be careful with number 4 because one of them is a less than, one of them is a less than or equal to, so you might have an open or closed circle depending. And when you're done with that, move on to the next slide. Okay, so on this slide, we're actually going to solve an inequality that's kind of like in between two locations. So for number 1, we have x plus 4 is essentially between 8 and 15. So the way that I approach this is I think of it as two separate inequalities. I kind of branch myself off here. The first way I'm going to look at this would be as if this was my only inequality, x plus 4 is greater than 8. And then the second idea would be as if that was its own inequality. So really I'm just trying to solve two inequalities. I know that in order to get x by itself in the middle I need to subtract 4. So I'm actually going to do that on both sides of this compound inequality. I can show that I'm subtracting the 4 in the middle as well. So that becomes a 4. We copy down the less than symbol. These 4's now cancel. Copy down the less than symbol. And 15 minus 4 is 11. So what I'm left with is something like I saw on the previous slide where I can plot down a 4. I can plot down an 11. They're both open circles because they're not the equals 2's. And I connect the dots. Okay, I'm going to try number 3. I'll have you guys try 2 and 4. Same idea here, you just kind of like branch yourself off a little bit. In order to solve this one, 2x plus 1, I'm going to need to first subtract 1 from each component. -2 minus 1 is -3. This becomes just 2x. And this becomes 5. Okay, and the last step is we have to divide everything by 2 to get x by itself. I'm going to put the answer up here. I don't want to run out of room. I'm going to get -3/2 less than or equal to x less than or equal to 5/2. So it's a little messy, but we can still plot fractions just like we can plot regular integer numbers. And I know I'm going to put a closed circle because both of these are the less than or equal to's, and then I connect the dots. So sometimes you'll have to deal with 2 steps in the middle like number 3. Sometimes it's easier like number 1. Alright, so I'd like you guys to try 2 and 4, see how you do with that, and we'll get some practice during our next class.